I'll throw you in the lake. Cool. And then who really wins? It's pretty cold today.
You know what I love is when I catch students threatening other students on camera.
Oh,
It's a great time.
I thought I was gonna throw her in the lake.
I'm soon.
Oh no, that's so tough.
Alright. So let me quickly see what homework questions, or let me see that you try the homework questions, and then we'll see what questions you need to ask.
The only thing I messed up on was when we had to do the fraction.
Well, luckily for you, I'm stopping at E today.
E. What do you mean E?
I did my homework.
12E.
Oh. Yeah, I did all of it. I didn't really know what to do there.
Pretty good start.
Shelby, are they still doing fishing tournaments on the weekends?
What'd you say?
Are they still doing fishing tournaments on the weekends?
Not every weekend. My next one's like
I know how to do.
February.
Oh look, it's like I can predict the future.
Oh, okay.
Oh wow.
I was talking to someone, they were like, it's
I mean,
too
the
cold to
stuff
go
that
fishing. I was like,
I
it's never
see.
too cold to go
You
fishing.
mean the
Let's
points
do
I
that
gave you
tournament.
yesterday?
Yeah, we'll still have them.
Corel.
But I mean, it might suck.
And I see y equals y over 1.
Fishing never
It's
sucks.
a
Fishing is always great.
It's less
That's
than.
a lot.
Hunting
Some
sucks
points better.
sometimes.
I did. I
Because the
I
shooting
gave
house
you some
can be really
points.
cold, so
Not all of
that's
them.
gonna be.
If it's like if yours, I did this one tournament. I went to Gunnersville and I just poured down randomly. I didn't catch a single fish all day. That
Okay,
sucks.
that would suck. Yeah, that would kind of suck. But you catch some really big fish while training though.
Yeah.
This guy got 100 points out of 150.
No.
Divide by 2.
No.
Divide by 8.
No.
Divide by 3.
I'll pray about it.
I'll pray
Alright, so
about
we're
it.
just missing Kelsey.
Yeah.
Alright. I really hate it for
Realize I have
Kelsey,
my
man.
Mhm.
She has missed so much because
I thought she left. They go to Mexico.
No, she
I saw her at
she's
lunch.
supposed to do that next
Yep.
night.
I saw
Alright.
her at lunch. What do you mean?
She got. She wasn't at lunch. She got checked out.
Yeah, she came by during fourth period to tell me that she had to go back into
How many
quarantine.
times has she been exposed?
I don't know. I've never seen a single person. I haven't had a single person miss that many because of
She
being
has
exposed.
got to stop going to
You
parties.
got it.
Can she just
Did
get a
she or
negative
did
test
I?
and
Did
come back?
you?
No, why would I cry that she had to
You don't
go?
love it as teacher then.
Huh?
That mean you don't love it as teacher then.
Oh, yeah.
That mean when we graduate, you're supposed to be crying like, I'm gonna miss him, I'm gonna miss her. But you don't do that, so that mean you're not a real teacher. That mean you don't love
You know how
it.
many
Okay.
classes he's probably had come through
Okay,
here?
that's Ken, I know.
He can't remember everybody's name at every single class that he's ever
I
taught.
promise
Yes,
you'll
we will.
read you thing.
Shelby, you're not wrong about that. All right, let's get started going over this homework.
That kind of hurts. Not really.
First off, any questions that you know you have based on what you see up here before I start talking about some important things to note.
The solution,
What about the solution?
the file.
The 5, 4?
Yeah.
So one thing to be aware of is I just picked 1 point. How many points are there that could be solutions?
Infinitely as many.
Okay, why are there infinitely many?
Because it makes a line in between all them points and makes the solution true.
Okay, well the equation.
Equation.
So let's actually check this point right here. That's the point 0, 2. You good with that point?
Yeah.
Okay, so if I'm using the point 0, 2,
Just like I did.
alright,
Why you shade it? Why you shade the parts? Oh.
we're gonna talk about that. So y is greater than -3/5 x plus 2. So 2, the y value, is greater than -3/5 times x, which is 0, plus 2. What's -3/5 times 0?
0,
What is 0 plus 2?
2,
Is 2 greater than 2?
no,
So are the points on the boundary line actually solutions?
no.
Oh.
Oh. Did you notice how I dashed this boundary line?
Yes.
Why did I dash the boundary line?
Because it looks nice.
No.
No, is it because
It's
you
not continuous.
can't equal it?
Not because it's not continuous. Say again.
Because you can't equal it.
Because I cannot equal it. You see how it just says greater than right here?
Yes.
Does it say greater than or equal to?
No.
No. Remember how if I got x is greater than 3, and I were to graph that on a number line,
So why don't you
would that
dot
be
it?
an
Why don't you
open
dot
point
it?
or a closed point?
So why don't you just dot it?
3, open or closed? Open, right? And then I would shade to the right. If it was x is greater than or equal to 3, then I would have a,
Close, because it could be equal to.
because it can be equal to, so it would be closed, then I would shade to the right. A dashed line you can do dotted if you want, it's just easier to dash it. A dashed line is just like an open point. If you cannot equal it, it's an open point. If you cannot equal it with two variables, then it's a dashed line or dashed curve. But if you can equal it, it's a closed point, or on a two variable one, it's a solid line or solid curve. Does that make sense? Right? So notice that point on the line did not make the inequality true. However, there still are infinitely many. You asked why did I shade up, right? Well, because all of the numbers above the line make the inequality. Notice I tested this point right here, 5, 4. That's this, right? 4 took the place of y, 5 took the place of x. Notice I only chose one point, but all of the points above would work. 5 divided by 5 is 1. What's negative 3 times 1? Negative 3. What's negative 3 plus 2? Is 4 greater than negative 1? So that's why I shaded up. All those values are the solutions. However, you could have looked at this inequality and known I was going to shade up. Why, looking at that inequality, do you know I'm going to shade going up? Any guesses, predictions, thoughts? What about the sign, Cordell? That's less than? That's greater than. Which direction would be greater than? Up or down?
Up.
So why? So I shaded. Notice I checked that point, and that point made the inequality true, so I felt pretty comfortable with that. I also checked this point 0, negative 4, right here, and I ended up getting negative 4 is greater than 2. Is negative 4 greater than 2?
No.
So did I shade down?
9.
No. See those connections? We go with that idea? But I want you to notice, and this is the part that's going to come back up within the objectives. Are you saying no, Devin? Or you're not good? Are you were shaking your head no when I asked if you're good. So you're not good? Okay. That's what I was a little confused about it. You were shaking your head at times when I wasn't. It just made it unclear. Yes, Peyton.
Doesn't the United States run a different mass system than everyone else?
What?
Yes.
Nothing of science.
There's a weird thing. Well, it's not everyone else. There's U.S. customary units. Like we have feet and inches and all that stuff and miles. Most of the world runs off of meters, centimeters, and kilometers. We run off of pounds. Most of the rest of the world runs off of kilograms. Right? So we have different units of measurement. Okay. There's something else I was going to say with this, but I don't remember what. Oh, what I was going to say is, notice the primary focus for these inequalities is you first need to identify what? What is this thing called?
A line.
Not just a line. There's a special name for this
The
line.
boundary line.
The boundary line, right? Because do I shade beyond it?
The special property line. I call it the property line.
Okay, you call it a property line. I'm going to continue calling it a boundary line. But notice it's bounding the shading, meaning it's restricting the shading. And then I'm shading what? What is this region going to be called?
Solution.
A half plane. It is the solutions, but we're shading a half plane for those solutions.
Yep.
We go with those ideas. Okay? Any questions about number 12?
No.
I will say this. I assigned all of number 12 last night, but I decided to let part of it be tonight's homework because we're a little bit off from where I thought we would be. So you need to make sure that you copy down A through E, because F through I think M is going to be for an accuracy grade tonight for homework. So if you're not sure about any of these things for A through E, you need to ask them now, because you're going to be using it tonight for F through M. You have a question, Desiree? Yes, ma'am.
What are the circles?
Say it one more time.
The circles.
Right here.
Yeah.
Those are actually just the points I chose for F and for I. So you can use those points if you want to, but you see how there's F and I on there? So I was circling those points to indicate those are the ones I was choosing. Everything else good for A through E? Every of you copy down A through E?
Hey, 6.
6.
6.
We're about to talk about 6. But we all get it on A through E before we move on?
So how would that work on Schoology for the people that are remote? How would you do all this?
What do you mean?
Are they working on the same thing we are right now?
I mean, if you're on Edgenuity, you're just doing Edgenuity, but if you're remote, I post the slides and the materials on Schoology every single day, broken into each day, and I post the videos on there as well so they can follow along.
So what exactly is the difference between remote and ingenuity?
Edgenuity, you're doing your own program. You're no longer doing what we're doing in class.
Ah.
If you're remote, remote is more, hey, you're in quarantine, so you can't be at school.
So could you go remote, but so what if you wanted to come to this school next year, but you didn't want to be here this year? Would you do ingenuity or remote?
You would have to do Edgenuity.
Ah,
But people can come back after the semester, so we may have some people back in the spring. I don't know yet.
this school's too crowded. You don't need anybody else.
All right, let's get back to this. I want to talk about something with number 6. First off, I think someone asked about 8/3.
Yes, I did.
Peyton, that was you.
Because I mean, I looked at it and I thought about it. Yeah, I could do the fraction, but he's probably just gonna want like a 1/2 or like something like that. I didn't figure.
So to me, it sounds like though you're just kind of guessing and checking and plugging stuff in for x. Is that what you did?
Yes.
Okay, but you're making your life actually harder doing that. You can do that, but like if I'm looking at, let's try A. What can this 2 take the place of?
Y. Or not Y, X.
That's taking the place of x?
Yes.
So 3 times 2 minus y is equal to 8.
So it's basically 6 minus something's equal to 8.
So what could I do now to find the solution to this equation?
What is 8 more than 6?
Just check.
Can we use our inverses?
Yep.
What is 6 minus 6? And then what's 0 minus y?
Or negative 1.
Negative y.
Can that negative just disappear? No. Remember how we talked about that a lot yesterday?
Yes, negative y.
So negative y equals 8 minus 6.
2.
Ah, I see.
Now what would I need to do?
I don't know that.
Well, what do I want on its own?
Y.
What's with the y that I need to get rid of?
The negative.
Now, how can I get rid of that negative?
Let's check that.
Negative y. Add y.
You could actually technically add y. That's not what I would have thought. We'll come back to that in a second.
Divide.
I would divide personally.
But
By
you're
negative
not
1.
multiplying.
Because notice,
But-
what is a negative divided by a negative?
Whoa, you can't divide. You're not multiplying anything.
Actually, you are. If you have negative y, this is implying to be negative 1 times y.
Oh, okay.
Negative y is implied to be negative 1 times y.
My first time learning it.
Hmm.
Does that make sense though?
You know it.
I mean, the only way, because like, what is 1, okay, look at it this way, what's 1 times y?
Y.
Okay, well then,
And then there's
can you
negative.
add it?
We'll talk about how we could add in a second, but notice, I can divide by a negative 1 because a negative divided by a negative is positive, and then what's y divided by 1? And so y would equal what?
-2. Or,
You're right.
yeah.
Now let's talk about what Carell said a second ago. He said we could add y. You're right. Because what's negative y plus y?
Y. 0.
Right? Negative 5 plus 5 is
0.
0. So those are the additive inverses creating the additive identity. 0 is equal to, and that's just literally going to be 2 plus y. But I don't want 2 plus y, I just want
Well, y equals
what y is equal to. So what do I need to get rid of?
the y.
The 2.
I got you.
What would I do to get rid of that 2, to undo it?
Subtract.
2 minus 2?
0.
0 minus 2? Does that give me the same answer?
Yes.
Notice here, if I divide by a negative, it just takes 1 step. Here it took 2 steps. That's the only difference though.
Yeah, I do the other way.
But either way works. That's just not as traditional. Is it okay to be non-traditional?
Yes.
Yes. Please understand, I love non-traditional thinking. You just have to be careful with it sometimes to make sure you don't make a mistake. But notice, Peyton, that gives me that negative 2 up here. Well, in the same way, what could this 0 take the place of?
Y. Or X. I mean, it's a 0, so.
Well, it's not.
Well, no, actually, I can't take the place of X because I would, yeah, just Y.
That's a point, x comma y. So what is 3x minus 0?
8.
That's just 3x, isn't it? Notice, this should be a very straightforward process. What can I now do to solve for x? 3 divided by 3 is? Is that a little bit easier than you made it, Peyton?
Yeah.
I need you to recognize that if you can plug in that x or plug in that y, all you then have to do is solve the equation. Find out what makes the equation true. Use your inverses. Use your properties of equality. We all good with this information? We good with that? Yeah? Okay. I want you to pay attention to some things. I'm going to talk about an important detail that's going to help us with the rest of today's task as we finish it up later. Have you noticed that B and C were exactly the same? Well, not the same numbers here, but the same here for numbers 4, 5, and 6. Why do you think they had us do a 0 comma something and then a something comma 0 for all three of those? Well, let's create a different mathematical representation maybe to see. Where would 0, negative 8 be on this graph?
And middle, like top. You said negative 0?
0, comma, negative 8.
On the top line.
This one?
No, on the bottom line.
This one?
Yeah.
Where?
1, 2, 3, 4, 5, 6, 7, 8, right there.
Why is that point important? All the way up, that's right. It's the what? It's the y-intercept. The output, when the input is 0, is known as my y-intercept. It was pretty easy to plug in that 0, wasn't it? And then find out what x was? Or to find out what y was in that case? Where would this point be? The x-intercept. 1, 2, it's going to be about 2.6 repeating, so right around there. And so now I have my x and y intercepts just from those zeros. Now, this is probably the equation of what type of function? Do you think it would be linear or exponential? I mean, if it's exponential, what do we need? Repeated multiplication.
Or repeated division.
Okay. But how do we show the idea of repeated multiplication within
Powers.
exponent of power, right? That's why it's called exponential. So is this exponential or is this linear?
What's the traditional word for it? A power or an exponent?
I don't know. I think they're both useful.
Whoa, hold on.
Kenny doesn't know something?
Right, hold on.
Hold on.
Okay.
There was more that
I'm
I
not.
think, as far as I'm aware, they can be used interchangeably.
Okay, but what was the traditional way?
You mean like historically?
Yes.
That's a good question. I'll find out during enrichment.
Crap. Something you don't know.
There's more that I don't know than you think. There's just...
That's just, wow, I never thought it to the day.
Okay. But notice we have 2 points. So is this going to be linear or exponential though? It's going to be linear, right? It doesn't have an exponent. So it's going to be a line. Do I currently have enough points to know what the line looks like? Or to be able to graph that line?
No.
No.
Why not?
I mean, I guess you
You
could.
go from dot to dot.
I mean- Is there a line right there?
Yes.
So do I have enough points for a line?
Sure.
How many points do you have to have for a line? 2. Usually I ask you to do more, but can you draw a line through 2 points?
Yes.
So if you need a line, or more specifically for what we're looking at, a boundary line, what 2 points can you easily find to create a boundary line?
The X and Y.
The X and Y,
Axis.
not axis.
Coordinate.
It's when it intersects the X and Y axis.
X-intercept.
X-intercept and,
Y-intercept.
okay. So it's not X and Y axis.
Oh, I said axis.
Yes, right, so the x-axis is this whole thing, the y-axis is this whole thing. We need the x-intercept and we need the y-intercept. Right? So if you need to find a boundary line, if you just do 2 points, you could be good to go. And the x-intercept is the input when the output is 0. And the y-intercept is the output when the input is 0. And we'll talk about that again in a second. So I want you to notice, it says right here, to ID boundary lines, you could find your x and y intercepts, right? Another option to find that boundary line, though, is you could use a point, which the y-intercept counts as a point, and then use the slope. Those are two of the major ways to find the boundary lines. We're going to focus more on this one over the next lesson or so, but isn't this what we've traditionally done in the past, of a y-intercept and a slope?
Yeah.
We go with those ideas? Okay. So I bring that up because it's going to come back up later today. Emory, you've been gone 2 days and you already got your head down? You didn't get enough sleep over the last 2 days? Come on. I need you paying attention and learning. So let's look at our objectives. Let's get started on 5.2, too big or not too big. I don't think we'll get to 5.3 because I haven't earlier today, so we'll just focus on these first two and then we'll look ahead at the end. So, who read yesterday?
Desiree
Me and
and
Shelby, I think.
I was Desiree.
I was at the day before.
Maybe before. I know we called Desiree.
I'll pick 2 other people then. Layla, can you read our first objective?
I can identify and interpret the boundaries lines for the constraints of this scenario.
What are the 2 main ways we just talked about to be able to identify the boundary lines?
Find x and y intercept.
X and y intercepts and
Use point slope.
use a point and a slope, or slope and y intercept. Both of those will work. Notice I have it clarified right here. You can have a generic point or you can have the y-intercept. Right? That's your starting point and that's your rate of change. So we need to be able to identify, but we also want to talk about how we would interpret the boundary lines, and we'll talk about that a little bit more in a second for the constraints of a scenario. And then we need to... Corel, can you read the second objective?
Okay, I identify all values that satisfy the constraints of an inequality to a shaded half plane.
Okay, when we look here, we needed a boundary line, right?
What is it? Oh, a shaded half plane.
And then the shaded half plane is above it, right? That's what we're looking at, but we also want to make sure that we understand that we're doing it in the context of constraints of the real world. Did we finish through number 7 in class yesterday? Everyone look at the number 7.
Y.
We all talk about it together. No, that's number 7.
Y is less than or greater than equal to.
Okay, Corel, I want you to think about what you just said. Less than or greater than.
Less than equal to.
Thank you.
I
Yeah.
have been doing
Hey,
that.
it could be less than or greater than. He doesn't know, man.
There actually are some cases when it can be both less than and greater
So I
than,
was right.
Yes, 'cause it
or
could be
greater than, but
negative.
that is not what this says.
Because it could be a negative.
Okay? Y is less than or equal to negative 2/5 x plus 16. Now, I want to point this out, right? Because yesterday we identified this boundary line, and then we shaded below the boundary line to indicate everything that satisfied the constraints that we could not go over $1,280. So one thing I want to point out is, in order to get this inequality, what did we actually write first in number 5?
Y equals.
So we use y equals mx plus b, because that's known as the what equation?
Point slope. Slope intercept.
Right.
I know.
That's known as the slope intercept. And from that, we identified what the slope was. What was it? Negative 2 divided by 5, or negative 2/5. So we want to start getting away from saying over. Over is not a mathematical term. Divided by, or negative 2/5 is a fraction.
Divided by 5.
There we go. X plus, what was b? 16. If I didn't care about your mathematical understanding, I would just let you keep saying the wrong thing. It's okay. But as Peyton says, it is really aggravating having a teacher who cares.
It is.
It's so rough.
Yeah, it's more aggravating, when the teacher corrects him, but I always get corrected by,
Shelby?
not calling names, but the tall one.
No, you're
It's okay. You could correct her. I mean, I correct her, don't I?
I could, but I can't even hear her, and I'm not gonna ask her to repeat it because it's.
So notice what we started with though, before we did the inequality, we wrote the equation of the what? What kind of line? Boundary line, right? We started with a boundary line.
Cause like John said.
I would write this down under 7 to note the fact that we're starting with the boundary line, because when I look at this inequality, isn't it almost identical?
Yeah.
What's the only difference?
Less than equal to.
Right, the inequality symbol is the only difference. Yes, that's right.
So you like that, number 7?
I would include this little note on number 7 because it will help you to study for the future. This right here, you don't already have this?
I have it, there's on number 5.
You should have this on number 5,
Oh, yeah.
that equation on number 5, but notice this is the inequality.
Oh.
Let's say a sign that less than or equal to.
Say again?
I was trying to say a sign less than equal to.
Yeah, so notice we started with the boundary line, and then we use that to write the inequality. And why did we know it was going to be less than or equal to? First off, why did we know it was less than?
Because it's
It's points below that boundary line, right? Why is it equal to?
Because it's equal to 16.
I mean, say again?
It's equal to 16.
Not 16. Every point on this line
Makes it true.
satisfies the constraints, right? Because how much could they spend? 1,280. When I looked at each of these points, did each of these points add up to exactly 1,280?
Yes.
Could they spend that much?
Yes.
So can we include the line?
Yes.
Okay. So notice, should this be a solid or a dashed line?
Solid.
Solid. If we can equal it, it should be solid. Does that establish everything pretty well?
Yep.
Comfortable with those ideas? Because you got to do it on your own on number 8.
Oh, no.
Oh no!
I don't know about that one.
I don't know about that, Mr. Kennedy. I don't know. All right. Let's look at number 8 here. Everything you did with numbers 1 through 7 is going to be summed up a little bit more with this number 8. In addition to startup costs, Carlos needs to consider how much space he has available based on the following. Space. Cat pens will require 6 square feet of space, while dog runs require 24 square feet of space. Carlos and Clarita have up to 360 square feet available in the storage shed for pens and runs. Write an inequality to represent the solution set for the space constraint. And shade the solution set for this inequality on a different coordinate grid. So notice this is not going to go on the same grid as what you did the startup cost for. This is going to be its own one. Now you could put it on the back side of that graph, and I'll bring graph paper around if you still need some. But are we looking at startup cost anymore?
Oh.
Should you be thinking about any of the numbers for startup cost?
Oh, we're talking about square feet.
Only
Square feet.
thinking about space.
Space and no square feet, same thing. Right, Miss Skin?
Say again?
I thought square feet and that's the same thing as.
Well, square feet is the unit of measurement for the space.
So that would be the y-axis.
No, because remember the y-axis and the x-axis are the variables. What are the variables? What things are changing?
Dogs and cats.
Dogs and cats. That's still going to be the case. And our x-axis is still going to be
Cats.
cats, and the y-axis is still going to be
Dogs.
Alright, now, strategically I want us to think about this together for a second.
You gonna help us?
Are you going to be able to write the inequality, at least yet, without the graph?
No.
No, we need that graph, because what do you need first to be able to write the inequality?
Boundary line.
The boundary line, right?
Or property line.
Or the property line, as Payne likes to say. And if you want that boundary line, you kind of need to graph it at this point. There is a way to find the inequality without the boundary line. That's what we'll start studying tomorrow. But we need that boundary line. What is an easy way that we could find the boundary line?
The x
I mean, wait,
intercept.
hold on.
X-intercept and?
Y-intercept.
So proud of you right now,
There
Corel.
is a way you could write the inequality.
Say
without the
again.
boundary. There should be a way you could write the inequality without a boundary line.
There is.
Yeah,
That's what we're gonna talk about tomorrow.
So I'm
cause
getting to it.
I just did mine, it'd be 24x plus 6y is, less than or equal to 1,280.
You're close and you have some correct ideas, but that does not quite work. We'll talk about it tomorrow. Hold on to that idea. But what I want to point out is we do want a boundary line, right? We have a line here. We had a line. This is the last problem, though. There is a line here. What are the ways that we have learned to write the equation of a line before? There's only been two that we've studied so far,
Point slope and slope intercept.
right? So we got point slope and we got slope intercept.
How many ways is there to write this?
3.
What's that?
It's called standard form. That's what we'll study tomorrow. It's actually very close to what Peyton just said.
So paint no song with it. Okay.
Yeah. So slope intercept, right? Or point slope. Does it matter which one you start with for the boundary line?
You
No.
should've taught us that last one last year.
Say again?
You should have taught us the standard form last year, that way I could just wrote it, because I don't like point slope or slope to intercept.
Oh, I'm sorry. There's times where you need slope intercept or point slope though, because the standard form does not always work.
Why?
We'll talk about it tomorrow.
He's making sure you don't skip his class.
Well, not just that. Let me go ahead and clarify this detail. When I look at this slope intercept, right? That m, what is that m?
The what?
Y equals mx plus b, it's the rate of change.
It's the rate of change, the slope, right? If you use standard form, Peyton, you don't use your slope.
So why do you think it was more important to teach us slope intercept and point slope other than standard?
Well, so slope intercept and point slope are much more prevalent because you're going to use that additive rate of change in a lot more situations. Anytime that there's a rate of change given to you, then you're going to use that slope intercept or point slope. And that happens more frequently than what you see in standard form.
So can you give me a situation where I'd use standard form over point slope or slope intercept?
Anytime that you're repeatedly adding with two variables at the same time.
So last year.
No. Last year all we did was we looked at repeatedly adding with
Wait,
one variable at a time.
That would be in this case.
Correct, which is why
Well,
we're going to use
actually-
standard form here.
So if I would have put d of x and then c of 6 or something, would that have worked for my inequality? Because that's when I put it first, but then I thought about it, there's no possible way
We'll
to
come
write
back to it tomorrow. Just hold on. We'll get there. You got some correct ideas, but you're messing up a couple of things. It's okay. But that's why we use slope intercept and point slope, because we have that additive rate of change for a single variable or for this exchange rate idea. But you're going to use that standard form anytime you're repeatedly adding or subtracting by two different variables at the same time, which is what we're looking at here. And most of y'all have actually seen the standard form within these first two lessons. You just didn't realize it. So we'll talk about it. But I want to emphasize, and I want you to remember, right, the slope intercept form is an equation of a line. The point slope equation is an equation of the line. And then, but that's because the slope is the additive rate of change, and slope is calculated as rise divided by run. A lot of students have been mixing those terms up recently, and you need to keep those ideas straight. Alright?
But you just said slope intercept as the form of the line and point slope as the form of the line.
Yeah, they're two different forms of the line, they both work. Yeah. If you actually simplify point slope anytime you use it, you get the slope intercept. And you can actually go from slope intercept to point slope, and you can go from slope intercept to standard form. They're all different forms of the same line, they just are written differently, meaning that they are effectively the same or equivalent. So you can use either equation.
I think you're making everyone's head hurt again.
I'm sorry that you feel that way. But we are going to try to write the equation of the line. So we need point slope, we need slope intercept, one of those two. But Corell was correct. To get us started with the graph, we might want to think about
X.
and
Intercept and Y intercept.
okay. So that is a good hint to get you started. I want you working within your small groups to take about 10 minutes to work on this space and to try graphing and writing the inequality. All right. You're only thinking about space. Do not think about startup costs. And let's get to work.
What would you skip by for space?
Huh?
What would you skip by for space?
So instead of me telling you, why don't you find your x and y intercepts first and then consider that for when it comes to,
Question.
sir.
So with this work as an inequality before I start the graph,